Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be discussing Section 5 of Chapter 7, Factoring Trinomials where the leading coefficient is 1. So we're going to begin by looking at Problem 1, Number 1. What is the factored form of x squared plus 8x plus 5? So in order to factor a trinomial, we have to figure out factors that multiply to a certain number and add to a certain number. So first, let's talk about what we multiply. So we need to multiply the number in front of your highest exponent in front of the x squared term. In this case, that's a 1. We multiply the 1 with your constant, the number that doesn't have a variable. In this case, that's 15. 1 times 15 gives me 15. So I need to figure out two numbers that multiply to 15. But in addition to multiplying to 15, these two numbers also have to add to the number that's right in front of just the single x. In this case, 8. So I need two numbers that multiply to 15 and that add to give me 8. Those two numbers that multiply to 15 and add to 8 would be 3 times 5. 3 times 5 is 15. 3 plus 5 is 8. So what I'm going to do, I'm going to use the numbers 3 and 5. And I'm going to rewrite my polynomial that I was given with 3 and 5 instead of the 8. So we're going to rewrite this as x squared plus 3x plus 5x plus 15. And we are going to factor this using our GCF properties, one binomial at a time. So I'm going to split this in half to create two binomials. I'm going to factor the first one by taking out the GCF. So between x squared and 3x would be an x, and I'm left with x plus 3. Between 5x and 15 would be 5, and I'm left with x plus 3. Now, when I factor this way, the whole point is to get these inside binomials to match. If they do, that is part of my final answer, x plus 3 times the numbers on the outside make my other binomial. X, it's a positive 5 plus 5. So when we factor trinomials, they're going to factor to give us a binomial times a binomial. And if you think about what we did when we multiplied these, we distributed everything. This would be x times x is x squared. X times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. If you simplified that, it would give us back the polynomial we started with. So as we go through factoring trinomials, we're going to have to know our multiplication facts in order to quickly and efficiently get the factored form. So let's also take a look at number 2. We want to factor r squared plus 11r plus 24. So in order to factor trinomials, what I have to do is take the number in front of the squared term, in this case 1, and multiply it with the constant, in this case 24. 1 times 24 gives me 24. I need to think of two numbers that multiply to 24 that also add to the middle number, which in this case is 11. So two numbers that multiply to 24 but add to 11. Those two numbers, of course, would be 8 and 3. So I'm going to rewrite my trinomial with 8 and 3 in the middle instead of 11. So this would be r squared plus 8r plus 3r plus 24. Once I've rewritten it, I've made it 4 terms. I'm going to split it in half, and I'm going to factor by GCF each side. So r squared plus 8r, I could factor out an r, which would leave me with r plus 8. 3r and 24, I could factor out a 3, which would leave me with r plus 8. Again, the whole point of factoring this way is to make sure those insides match. If they match, that becomes my first binomial, r plus 8. And then the numbers that were on the outside become my second binomial. In this case, r, it was a positive 3, so plus 3. So this would factor to r plus 8 times r plus 3. And again, I could just multiply it back out using that distributive property to make sure I get the trinomial we started with. So let's keep going, looking at some more examples. Problem 2, number 1. We want to factor x squared minus 11x plus 24. So what I'm going to do, same process. I'm going to take the number in front of x squared, which is 1, and multiply it with my constant 24. 1 times 24 gives me 24. And I need two numbers that multiply to 24 that add to the middle number, negative 11. So in order for two numbers to multiply to a positive but add to a negative, both of my numbers would need to be negative. In this case, negative 8 and negative 3. And again, once you find your factors, check them just to make sure you're correct. Negative 8 times negative 3 is 24. Negative 8 minus 3 is negative 11. So we're going to use those factors to replace the middle. So this would be x squared minus 8x minus 3x plus 24. Cut this in half so you have two binomials to work with, and factor by GCF. We can take an x out on the left to be left with x minus 8. On the right, notice it starts with a negative, so I'm going to take out negative 3 to be left with x minus 8. Again, the whole point of this is get those insides to match, which they do. So that's my first binomial, x minus 8. And then x and negative 3 from the outside make my second binomial. So since it was negative 3, this one is x minus 3. Again, once you get your answer, multiply it back out. Make sure it does, in fact, give you what you started with. If it doesn't, it's not correct. So let's look at number 2. We want to factor y squared minus 6y plus 8. So I'm going to need to multiply the number in front of the squared, which is 1, and my constant 8 to get 8. And I need two numbers that multiply to 8 that add to the middle number, -6. So again, in order for something to multiply to a positive and add to a negative, both numbers have to be negative. In this case, it's -4 and -2. So I'm going to use the -4 and -2 to rewrite y squared minus 4y minus 2y plus 8. I'm going to split the binomial in half. Well, the polynomial in half to make two binomials, I should have said. And I'm going to factor by GCF each one. So on the left, take out the y, so you're left with y minus 4. On the right, take out -2, so you're left with y minus 4. The insides match, so that's my first binomial, y minus 4. And the outsides, y minus 2, makes my second binomial. Again, once you've factored it, take the time to multiply it back out and make sure it gives you your original polynomial. So let's take a look at number 3. It says, can x squared minus x plus 2 be factored? So to factor this, we would need to multiply the number in front of x squared, 1, with 2. And we would need to find two numbers that multiply to 2 and that add to the middle number, -1. Well, to multiply to 2, both numbers would need to be negative, and the only two numbers that multiply to 2 are 2 and 1. So -2 times -1 gives me +2, but they do not add to -1. So when this happens, when you cannot find two numbers that multiply to one but add to another, and there's no GCF in your problem, and this problem, there's nothing in common between those three terms, the problem cannot be factored. And we have a special name we call polynomials that cannot be factored. These types of problems are called prime. We cannot break them down to anything except for itself times 1. So number 3, no, it cannot be factored, so we call it prime. Okay, our next problem, problem 3, number 1, we want to factor x squared plus 2x minus 15. We're going to take the number in front of x squared, in this case 1, and multiply it with -15. So 1 times -15 is -15. And we're going to need two numbers that multiply to -15 that add to the middle number 2. So for two numbers to multiply to a negative but add to a positive, they're going to need to be different signs. In this case, +5 and -3. 5 times -3 is -15, and 5 minus 3 is 2. So I'm going to rewrite this as x squared plus 5x minus 3x minus 15. Once I rewrite the polynomial, I'm going to cut it in half and factor by GCF. On the left, they have an x in common, which leaves me with x plus 5. On the right, they have -3 in common, which leaves me with x plus 5. So this is going to factor to x plus 5 because the insides match, and x minus 3 because those were the terms on the outside. So this time I'm going to have you try number 2, A and B, and see if you can factor those polynomials. If you factored A correctly, it would have factored 2n plus 12 and n minus 3. If you factored b correctly, it would have factored to c minus 7 and c plus 3. So now let's take a look at one more type of problem that involves two variables. So let's go down to problem 4, factoring the trinomial with two variables. So what we're going to do is the same process we have been doing. We're going to multiply the number in front of x squared with the number at the end that would be in front of the other variable squared. So in this case, we're going to multiply 1 with negative 55. So 1 times negative 55 is negative 55. And we're going to need to find two numbers that multiply to negative 55 that add to the middle number 6. So for two numbers to multiply to a negative and add to a positive, it's going to have to be a negative and a positive. In this case, 11 and negative 5. Now, the different part that's going to come in is when we rewrite it. When I rewrite the polynomial this time, it's going to be x squared plus 11, but instead of just x, it's xy in the middle. Minus 5, instead of just x, it's xy in the middle. Minus 55y squared. The moment I finish rewriting my polynomial, I'm going to cut it in half and factor by GCF. So on the left, it's x, which will give me x plus 11y. On the right, it's negative 5y, which would give me x plus 11y. So the insides match just like I wanted, so that's my first binomial, x plus 11y. The outsides, x minus 5y, make my second binomial. And again, once I rewrite it, I should multiply it back out, even if it's just multiplying it back in your head, to make sure that you are getting the polynomial that you started with. So let's take a look at number 2. We're going to factor m squared plus 6mn minus 27n squared. So I'm going to take the number in front of m squared, in this case 1, and multiply it with negative 27 to get negative 27. And I need two numbers that multiply to negative 27 that add to that middle number 6. In this case, 9 and negative 3. So when I rewrite, it's going to be m squared, but instead of just plus 9m, it's 9mn, since there were two variables, minus 3mn minus the 27n squared. Cut it in half to get two binomials and factor by GCF. So it's m plus 9n on the left. On the other side, negative 3n is what they have in common. So I get m plus 9n. Insides match, so that's my first binomial when I write this in factored form. And what was on the outside, m minus 3n, is my second binomial. So this concludes our lesson on being able to factor trinomials where the leading coefficient is 1. If you have any questions, please ask Miss Brooks. Otherwise, we'll catch you next time on your Daily Dose of Math with Miss Brooks.